Alright, so for FRQ2, we give this a plunger system with two masses. It's a spring. And so for part A, it asks us to derive an expression for the momentum of block 1 at point C. And so we can set up the equation that momentum final is equal to mv. And since m is already a variable, all we have to do is find v. We know that at here, the plunger system is at max potential energy, and at B, it will be at its final kinetic energy, which is a distance of d. So we can set up that PE is equal to, or P of the spring is equal to 1/2 kx squared, or kd squared. And then we could set up our equation that Ke max is equal to 1/2 mv squared. And then we can set the two equal to each other to solve for velocity. So we can get that the square root of k over m times d is equal to v. And then we can plug that into our momentum problem. So we get d square root k over m times v is our our equation for our expression for momentum. And then for part B, it has to draw three graphs, one of momentum, one of acceleration, and one of potential energy from point A to B. We know that the potential energy at D equals 0, which is at point A, is equal to its max, which then will decrease exponentially, like so. So this would be D max. Sorry, this would just be B, and up here would be PE max. And then for the acceleration, the over distance, we know that it will just be a linear line, as we know the acceleration will decrease as a function of time, because force is equal to kx, so ma is equal to kx. So these are related. So this would be a max, and this would be b. And then we know that the momentum graph would start at 0 and it would increase at a fast rate, but at a decreasing rate as well. So as the acceleration is decreasing, the slope also decreases until it stops increasing. So this is V max. This is point B. Now for letter C, it says to derive an expression for the acceleration of block 1 as it travels through point C through D, which is our patch of friction. So for this one, we can set up the force of kinetic friction is equal to Fn times mu k. Mu k is already a variable, so we can leave that. Fk is equal to mg, as Fn is equal to our mg. Mu k, we put Fk, we just put as ma, because force is equal to mass times acceleration. Yeah, mg mu k. Mass cancels out, so our function for A is equal to g mu k. Now moving on to part D, it says to derive an expression for work done on the block from point C to D We already found for our friction, our frictional force is equal to mg mu k, and we know that work is equal to force times displacement. So we can just put that the work is equal to mg mu k, as we saw for before, multiplied by d, which is our displacement. Now moving on to letter E, it asks us to sketch speed of center of mass as a function of time right here. Alright, so we know that it starts from rest. TB, TC, TD, TE, and TF. We know that it starts at rest and then it accelerates to its max velocity, which then it stops accelerating, it stays the same. And then once it reaches point C, or time C, it will then decelerate due to friction. And then it will stay the same from D to E, in which it will then decrease in speed again as it comes in contact with the other block, the other mass. And then we can now move on to part F. It asks if the mass of block 1 is to be doubled to 2m, the speed of block 1 at point B would, and the options are increase, decrease, or remain the same. The answer to that would be that it would decrease. And this is simply because more mass means more inertia, which means that it would take more force to move. So, more mass, more inertia. And since the force does not increase, then the acceleration must decrease in order to keep the force the same. So, less acceleration, which means less speed. For part G, it says if the mass of block 1 is doubled, the acceleration A from block 1 from point C to D, that would increase. And we know this because more mass means a greater natural force. Fn is bigger because the F of G is larger, which means that the frictional force would increase, therefore increasing magnitude of A. For part H, says if the mass of block 1 is to double from point C to D, what would happen to the work? Just like before, it would increase because as stated before, the frictional force is increased, and since work is equal to force times displacement, and we know that the frictional force is equal to mg mu k, as we stated before, and the d stays the same. Because the mass increase is doubled, our work will also double. Yes. And then for I, it says the plunger is returned to its original position, but it is now a sphere. And then it asks, in which intervals does the sphere's angular momentum about its center of mass change? And the only interval which this happens is from C to D. And this is simply because the sphere cannot rotate or have an angular momentum without friction. And from point C to D is the only part with frictional forces. So yeah, since from point C to D, that's the only part with frictional forces, the sphere can only spin during the interval C to D, or only change its angular speed from point C to D, and since angular momentum is equal to the moment of inertia times the angular velocity, then we know that the angular momentum cannot change without frictional forces.